In this video, we will be shifting the sinusoidal function y equals sine x. We have seen shifting in the past when it came to parabolas, and our shifting always took place with addition subtraction. We had the horizontal shift inside a bracket and the vertical shift outside the bracket. So we're going to be shifting to the right d degrees when you see x minus a number. We're always taking the opposite sign. And if you see x plus a number, you're going to be actually shifting to the left. Your vertical shifting is going to be very logical. If you see a positive number, so when c is greater than 0, you're going to shift up. When the c value is less than 0, we're going to shift down. So let's take a look at a few examples where we draw the base function of y equals sine x, and then we apply the shift, make some observations about our properties, and then maybe we can find a little shortcut. Okay, so first I'm just going to graph the basic sine x function. So I'm going to start at the origin, and every 90 degrees I'm going to go to a key point to create that wave look. Alright, so my transformation here for y equals sine x is just shift up 1 unit. Okay, so I'm going to take this base function and I'm going to take all 5 of those key points and go up 1. So the point that was at the origin is going to be at 0, 1. The maximum is going to be at 2. The midline at 1. The minimum shifts up to the x-axis, and the midline up to 1. There's my cycle. Now I can continue this pattern. I know every key point occurs 90 degrees apart, so I'm going to put the next key point at a maximum 90 degrees later, then at the midline, then at the new minimum, and the new midline. So there's another copy-paste of the function, or of the cycle, and I did it to the left as well. Okay, so properties. The domain is infinite, that's never changing. My range has changed. It used to be -1 to 1, but now it's from 0 to 2 for the min to the max. The vertical shift is just 1 unit up. And phase shift, that's just the word we're going to use for the right-left movement, which we don't have. And there we are. So the only thing that's changed here in terms of a property is the range. And the range covers the max and the min. And actually the midline has changed as well, because the midline is now at 1 instead of the original 0. Okay, let's go to the next one. I'm going to draw my base function. And now, this says x minus 90 degrees. That's going to be a phase shift, so I'm just going to write it in that blank right now. So we're shifting right 90 degrees. There is no vertical shift. All right, so I'm going to take this to the right 90 degrees. So the point that is currently at the origin is now going to be 90 degrees to the right. The maximum is now going to occur at 180 degrees. The point at 180 is going to be at 270. The point at 270 is now at 360. And the point at 360 is now going to be at 450. So everything just moved over 90 degrees. And I'm going to continue this pattern. Every 90 degrees, hop to my next key line or point. So up to the max, down to the midline, down to the minimum. There's a little bit more. I'll do the same thing to the left. From this point here, I need to go to the minimum, to the midline, to the maximum. And there we are. My domain again has not changed. My range actually hasn't changed as well. -1 to 1. So this time we didn't have that up down and my range didn't change. Just the start of that first cycle now started at 90 degrees instead of at the origin. Okay, let's try another one. Y equals sine of x plus 60 degrees. So start with the base function. Connect. Okay, we do not have a vertical shift because there's no number here that's attached by addition and subtraction. Our phase shift is in here. It says plus 60. We have to take it as the opposite sign, which is negative going to the left. So we're going left 60 degrees. Okay, so I'm going to take my origin point. I'm going to go to the left 60. 60 in this grid is 2 boxes because each box is 30 degrees. My maximum to the left 60, here it is, left, left, and left. And that gives me this as my new function, and I'm going to continue the pattern. So 90 degrees later, here's a new point. So I'm just counting. 90 degrees is 3 boxes, so 3 boxes later, I'm going to jump to my max. 3 boxes later, midline. 3 boxes later, minimum. 3 boxes later, midline. Connect. It's not looking wonky, good sign. And I'll continue in the other direction as well. 3 boxes to get to the minimum, and then I run out of space. My domain is good, negative infinity to infinity. My range, again, still hasn't changed because, like I said in the previous example, it looks like the vertical shift would be affecting my range, which in this case, we don't have a vertical shift, so the max and mins have not changed. All right, one more before we make some observations. Here's my base function. And here we do have 2 sets of transformations. I have a vertical shift of down 1 unit because of that -1. I have a shift to the right 20 degrees or 120 degrees. It says minus, I'm taking the opposite sign. Now I'm going to do both of these transformations at the same time. So I'm going to go from that origin point. I'm going to go down 1 and then 120 degrees to the right. So that's to here. So there's my point. Down 1, right 120. And I'm going to do that for the next one. Down 1, right 120. For the 180, down 1, right 120. For the minimum, down 1, right 120. And the midline, down 1, right 120. The shape of the original function should not have changed. It just got shimmied over a little bit. And now I'm going to continue my pattern. Now, because I did do a little bit of shifting, if it helps to draw in that new midline, the new maximum, and the new minimum so that you have a better guide when you're hopping lines to continue the pattern, you're more than welcome to. So now from this point here, I'm going to go 90 degrees to the right and hop up to the maximum. 90 degrees, hop to the midline, and then I've kind of run out of space. I'll do the same thing to the left, 90 degrees at the minimum, 90 degrees at the midline, 90 degrees at the maximum. And there we are. Domain is still infinite, but my range has changed. It's now from -2 to 0. So what observations can we make? The domain hasn't changed, but the range has whenever there has been a vertical shift. And if you take a look here, this vertical shift looks like it's matching my midline. And let's look above. The vertical shift was +1 and my midline was +1. And then the max and mins were just 1 above and 1 below because the amplitude was just 1. So let's put that together. The C value represents the midline or the central axis. So our midline is at y equals whatever that C value is. And then if we combine our A value and our C value, which I know our A value hasn't changed, it's just a 1 at the moment, it will affect the range. So our maximum is going to be the midline value of C plus the amplitude. The minimum is going to be the midline minus the amplitude. And then together, that will give you your max and your min. All right, Let's do 2 more examples where we're putting these transformations together. So we have a vertical shift down 2 units. And we have a phase shift. It says plus, but that means left 90 degrees. Now at this point, if I wanted to, I can try to skip a little bit of a step here using my knowledge of the A value and the C value. So this down 2 should affect my midline. My midline should now be at -2. And because my amplitude is just 1, right here, the amplitude is 1, I know my maximum should be 1 above the midline, and my minimum should be 1 below the midline. So that gives us a range of -3 to -1. And our domain has never changed. It's always been infinite, so I'm going to do that. Now, in terms of trying to skip that base function, you don't have to. You're obviously more than welcome to do it. But if you want to try to do this in one step, I know my original point on the sine function used to be at the origin. If I can just shift that original point, I know what the rest of the pattern should look like. So from that origin, I'm going to go to the left 90 degrees and then down 2. And there we are. I know this is correct because a sine function begins at the midline, and the point that I just plotted is a midline point. Then every key point occurs 90 degrees apart. So from this point, 90 degrees later, I should be at a maximum. 90 degrees later, midline. 90 degrees later, minimum. And then midline. There's my first cycle. And now I can continue the pattern for the rest of it. 90, 90, 90, 90, 90. And I'm just following the wave and in the other direction. And there it is. Let's try one more. Okay, vertical shift is up 1.5 units, and the phase shift is to the right because it says minus and we take the opposite, right 360 degrees. Now, my vertical shift also gives me my midline. So my midline, or my central axis, will be at 1.5. And then my maximum should be 1 above that, which is at 2.5, and 1 below at 0.5. So 0.5 to 2.5 for our range. Now, once our amplitude gets a little more interesting, instead of just a 1, it will affect our max and mins more than just 1 above, 1 below, but it's a good start for us. And there's that infinite domain. All right, I'm going to try to graph this all in one go. So I'm going to take the point that used to be at the origin, and we're going to go to the right 360 and up 1.5. This should be my starting point. And now, 90 degrees later, I'm going to hop to the max. 90 degrees later, midline. Minimum, then midline again. There's your first original cycle that has been shifted. And now I'm going to go backwards. Every 90 degrees, I'm going to continue this pattern. And that's it. So, in terms of your shifting, inside the bracket is horizontal and we're taking the opposite sign. Outside the bracket is your vertical, up is plus, down is negative, and your shifting predominantly affects your central axis, so that vertical shift affects your central axis, and if you combine that with your knowledge of the amplitude, if you add the amplitude, you get your max. If you subtract your amplitude, you'll get your min, and that will give you a nice range for where to draw those key points. And that's it for shifting. In the next video, we're going to put everything together to graph a more complete sinusoidal function that has been transformed.